In this video, we're going to be looking at types of functions, and this will be directly relevant and useful when we're looking at inverses and we're finding the inverses of functions. So to begin, what is the definition of a function? Well, it's a relation which has only one y value for each x value. So typically, sometimes you think for functions, well, they're just any sort of equation, but it does actually have to satisfy this, in which that there is only one y value for each x value. So that means that if you have a graph, so it's easiest to see when you have sort of graph here, then you have an equation here which looks like that. Well, this would be a function because at every x value, there is only one particular y value. So you can think about it like at every x value, there is only one corresponding y value for it. So you can see there, that is a function. However, if we had something like this, then this would not be a function because there at a particular x value, we'll say 0, there are two corresponding y values. Maybe let's say 0, 1, and then also 0, negative 4. So that is not a function. So the way you can, easy way to test this is using something called the vertical line test. So if you imagine you're going along a graph with a vertical line, or conveniently a ruler, you can go along and say that, okay, well, there's only one intercept every time I go along. However, once you hit this graph, you'll see that there are two intercepts, and then you know that it is not a function. And that's because the ruler represents one x value as its vertical, and then if there are more than one intercept, that means there's more than one y value which corresponds to each x value. So we'll do some examples of the next three functions. So firstly, we have the line y equals x along here. So if we take a vertical line, then we can look at every point. Well, there's only one intercept, there's only one intercept, there's only one intercept, there's only one intercept, there's only one intercept. And you can go all the way along, and then you see that, yes, y equals x is a function. Yeah. Looking at the next graph, we have y equals x squared, so a parabola. Then if we take a vertical line, we can go along. We see that at every point there is only one intercept. So you can draw lines if you want, but you should be able to see that no matter what x value you go along, there is only one corresponding y value. So that means y equals x is a function. So what about this graph here? Well, yeah, we'll look at it, we'll go along with the line. So if there's no y value, that doesn't matter, because with this function, there's no x value. See, there is an x value, there will be a y, but just to take note that if the graph doesn't span the entire domain, so the domain is not R, then it can still be a function. So that's fine, but obviously you don't have to worry about that section. Then along this point, it only has one intercept at x is equal to 0, which is 0, 0. But then if we go further, we see that there are two intercepts, there are two intercepts, there are two intercepts. So it is obviously not a function because at a particular y value, x value, there are multiple corresponding y values. So there's not just one y value to one x value. So this is not a function. So there's a particular type of function called one-to-one functions. So one-to-one functions are functions which satisfy the previous condition, but also satisfy that they only have one x value for each y value. So that sort of sounds like the exact same thing we said for function. But for the function, we said that there has to be a particular y value for each x value. This time we're saying there has to be a particular x value for each y value. So instead of meaning that you're going along at every x value there only has to be one y, now we have to also check that for each y value there is only one corresponding x value. So we'll look at the same three examples and we'll see if they are one-to-one functions. So first example, y is equal to x. Then we know we've already shown that this is a function. So we've already done the vertical line test and you can look at that. But now we want to see if each y value So each y value corresponds to one x value. So you can get sort of a ruler, or you can look at it horizontally. You can see that at every y value, so this y value here, there is one particular x value. Another y value, there is one particular x value. And you can go along and see for every y value, there's one particular x value. So y is equal to x is a function, as we've shown before. However, it is also a one-to-one function. So this is called 1 to 1, and it is a function. So what about this one here? So with this graph, if we look at each y value, there is only one corresponding x value. So there's along here, we can see that there's only one corresponding. However, it is not a function. So firstly, we've shown this before, that if you go horizontally at each particular x value, there are multiple intercepts. So this is not 1 to 1. Now this will be a particular type we'll talk about later, which is actually called one to many. And the reason why this is one to many is because it has one x value to many y values. But it's not one to one as not a function. So not a function. And I'll talk about why it's called that one later. But you have to remember that it's not a function, so therefore it can't be one to one even though it satisfies the later condition. So what about this one, the parabola? Well, if we do a vertical line test to see if it's a function, so we're going along here, then you can see that at each x value, as I've shown before, there's only one corresponding y. So it is a function. But is it a one-to-one function? We can go along here and then take a particular y value, and it has two x values. So that is not a one-to-one. And to see a numerical example, we know that the equation is y is equal to x, so we know that point here is, let's say, 2, 4. And then this point here is negative 2, 4. So we have the exact same y value, but we have two corresponding x values, which will give us this point. So therefore, it's not one to one. And then there's not a case for this one in which, let's say, negative 2, 4, that you have the same x values but different y values, because that means it wouldn't be a function. But it's not one to one due to this, like 2, 4, negative 2, 4. So where does this one to one, many to one to many sort of come in? Well, this refers to the x values to y values. So looking at the previous example, the parabola, we can call this one many to 1. That's because it has many x values to one y value. We can see that here. So there's many x values, 2 and negative 2 to one y value, 4 and 4. Obviously you could find other y values, however you just need to find one to satisfy the condition. So this is called a many to 1 function. So there are three different ones here. We have one to one, many to one, and one to many. The reason why one to one is called one to one is because it only has one x value to one y value. And it has to satisfy both the vertical line test and the horizontal line test. Then you have many to one, so that's many x values to one y value. However, it still satisfies the function, so like it passes a horizontal line test, but vertically you'll see that there are multiple intercepts. Now these two are functions, but the last one is not a function. So the last one is one to many, but you still need to know it, and that's one x value to many y values. So that is when we looked at before, the equations such as this one here, that's this one here, where vertically the horizontally it's fine, but vertically it's not. And then the last one is many to many, and that's when it doesn't pass or like pass either, but rather it has not like one x value to many y values, but then also has one y value to many x values. So probably the most typical example for this one is a circle. So if we have a circle, then the problem with the circle is that at a particular x value, so let's say x is equal to 0, we have two y values, and at a particular y value, let's say y is equal to 0, we have two, this is when x is equal to 0, we have two y values, so let's say 0, -1, 0, 1, and at a particular y value, we have two x values here, 0, 1, 0, and 1, 0, and that's -1, 0, and 1, 0. Now you don't have to worry too much about these two. Just remember x values to y values, and then it becomes a lot easier to remember. But just know 1 to 1 and many to 1, and remember that these two are functions.